Hi, Liv.
I am maybe
Yeah, how are you?
not good, not good. It's very slow. I'm very worried now. You say 16.
Okay.
I'm not able to make it.
Oh, why are you thinking that way?
I couldn't even complete the content yet.
Okay, no problem. So you're currently at which part?
Actually, I skipped the perceptron algorithm because I'm
Okay,
waiting for the webinar, and then I
okay,
just go ahead with the next one. Mm,
okay. No problem, no problem. So yeah, so if you think something is frustrating you or something, for now, maybe we can try to for the timing we can skip it
mm,
and like go further and see if in the project you are facing some issue, then you can come back. So yeah, because as you also know, it's almost mid June, and as we have to do the project,
yeah,
so it's fine if you want to skip some things which are a bit tough, and maybe just come back if they are required in the project. Otherwise, our first, I think, our preference should be just to complete the second project. Yeah.
yeah. So the second part was be mainly on the PyTorch more, right?
Yeah, so it will be basically on the PyTorch. So whatever you learn in PyTorch, the
Mm,
the initial content, that is neural networks and implementing gradient descent, training neural networks. This gives you the base, like how to train your models. So this will tell you the from scratch how do you build it, and the PyTorch just provides you some functions to do that in an abstract way. So basically, you'll start with like writing your own Python code from scratch and training your models, and later on, PyTorch will give you some normal functions or some one-line functions which will do your training or some parts of the training on its own. So yeah, so it basically starts with telling you from scratch how to do it on your own, and then it tells you, okay, PyTorch library has some good functions which you can directly use, and you don't need to write the code from scratch. So this is how it's structured.
oh, okay.
Okay, so yeah, it's important to go through the content before PyTorch also, so that you know how the PyTorch functions are internally uh, doing the stuff. So
Mm,
yeah, so you should go through the content, initial content, and then PyTorch will give you an abstract way, just calling the function and making the things work. So
I
yeah,
see.
and you can always so for this time, I can allow you to skip some things which are frustrating, and you can ask your doubts, and still it's fine to directly go to PyTorch.
Okay.
Yeah, also you asked some of the doubts yesterday also. I was seeing that, but I didn't reply till now. So maybe in this call or maybe just after the call, I'll reply to those also. Okay.
Okay.
Okay, great.
Can
Yeah.
I ask something about perceptron algorithm on the data.csv? I saw that at the bias there is a bias of one and zero, right?
Okay.
Is there a
Okay.
reason why we need to have a bias one and zero?
Okay. So actually, this is a good question. So let's think on how to decide on the bias. Okay.
Okay.
You want me to think on that, like to
Yeah.
discuss that with you?
Yeah. Sure.
Okay.
Because yeah,
So
I'm thinking which screen I should look at because
y-
there is a
yeah,
yeah.
yeah. Just just I want you to not to worry much. Okay. For yeah, so if you're worrying, don't worry. Just try your best, give your best, try your best to do the course, to give all of your time to the course, because it's still a lot of days left. There's nothing like a very less number of days are there, and a lot of content and things like that. You still can manage. Just don't worry much, and like try, like give all of your energy to your course and not to the worrying part. Okay.
Mm,
Yeah, that
okay.
is very important. So yeah, try your best and give all of your energy to the course and not to some other stuff which comes in your mind. So yeah, that is what I'll suggest, because that way it'll be better for you to like. So most of your time will be going on actually doing the stuff and not like worrying or something. Okay.
Okay, okay. Actually, I have something to talk about. This not also the not. I think is a bit wrong. Also, the correct output. If you
Okay.
scroll down to the not, that is actually,
Yeah.
is it
Uh,
the not?
yeah, I
The
think
not.
I myself coded
Not this
that
one.
someday. Yeah.
Yeah, this one is should be true, false, false, or because 0, 1, and 1, 0 should have the correct output of the same, right? Either they are false or true. So I don't do this test already because I feel the question is wrong. The correct output true, false is wrong, right? Should be true, false, false, true, something like that. Is it?
Oh, okay, so you're saying it's given as wrong.
It's
Okay, let
wrong.
me, yeah, yeah,
Is
let
it?
me
Mhm.
check. Okay, let me check. Actually, I don't remember exactly, so I'll just read it for a minute. Yeah, operation done zero if the input is one and one if it's a zero. Okay, the other inputs to the perceptron are ignored. Okay, so if the input is one, returns zero. So yeah, okay, it returns zero. So if it's one, it returns zero. If it's, yeah, I think you are right. One, it should return false. If it's one, it should return false. Yeah, okay. Tell me, what do you think should be the correct outputs?
Actually, I'm not sure which is the correct
Yeah, yeah.
outputs,
No
but it
worries.
looks
No
wrong
worries. Okay.
because I don't know. Not is a if a one then it become a zero. Is a zero
Yeah,
become a one. But
yeah,
this
yeah.
one with the two matrices, I don't know how to actually analyze that. If I say a
Yeah.
zero, I don't know how to see this one.
Yeah. Actually, you're right. Okay, so okay, I'll see that this one myself also, and I'll let you know because I understand what your query is. So you are basically saying, what should I see before? Should I see the one thing or should I see the zero before? That's correct, right? Because according to this zero,
Into my
the answer. Yeah, yeah,
0 and 1 and 1 0, they should have the same answer. It shouldn't be the different answer. But I don't know which is
yeah.
the correct answer. So I'm not going to do that. Why I don't have time to look at this one. So I quickly skip. But I have problem with the
No,
perceptron
so
algorithm. I think I need help on that one.
no, yeah. So I think what happens is basically, so as it's saying here, the operation returns a zero if the input is one, and a one if it's zero. Okay, the other inputs to the perceptron are ignored. Okay, so basically what it does is it just sees the first input. So
Oh,
if the
okay.
first input is zero, it just returns one,
Uh-huh.
which is true. Then it sees the
Oh.
first. If it's zero, oh, okay. Am I saying it correct or not?
Actually, I also don't understand the
Oh,
question, so I Mhm.
okay. Okay, I understand these. This also is fine.
It looked
Okay,
weird, right?
okay,
The element one and
okay.
element two look very weird. The answer.
Yeah, yeah. Okay, still, I don't want to tell you some vague answers. Okay, I'll go through this and I'll ping you in the chat later. Okay?
Yeah, it's okay. Yeah, I
Okay.
don't want to waste time on this one also because
Yeah,
my
no,
time
so,
with you is very precious. I don't want to waste on this one
yeah,
because this is the content problem, not the I don't understand problem, so I don't want to look at this
yeah.
one.
No, no, no problem. So I'll give my time for this. I'll take care for it and I'll just tell you the correct way to think, okay, directly.
Okay. Yeah.
Okay, great. Yeah. So on bias, let's think on that because some days back also someone asked me that. So I
Mm-hmm.
remember what I told and how we think on it. So yeah, let's go through this example. So we are basically want to make an and perceptron. Okay.
Mm.
Yeah, and now I think you are very comfortable in these lines.
Uh, yes,
Sorry,
this one
actually,
comfortable already.
yeah,
Yes,
yeah, yeah.
yes,
These all.
it's very comfortable already. Yeah, this one.
Okay, great, great. So very good. I can see, I can hear that confidence in your voice. So yeah, it's great.
When I worry, the voice also very worried. Is it?
No, it's really good. It's really good. So yeah, so okay, making an and perceptron. Basically, as we know, okay, I'll just write a comment here. So for 0, 0, as we know, making an and of 0, 0 is 0. Yeah,
Hmm.
and then I'll just write the combinations which we have. 0, 1 would be 0. Then can you tell me for 1, 0?
0.
Okay, great. And then for 1 comma 1.
0. 1 comma 1 1 1.
Yeah, great. Okay, so these are the required results for us. Okay, for 0 0 it
Mm.
should be 0. For 0 1 it should be 0. 1 0 it should be 0. 1 1 it should be 1. Okay, and what is the formula which we have in our hand? It's basically this formula.
Mm.
Okay.
Okay.
Yeah, so we have this formula. So okay, so this is what would be given to us. So test input 0 is given to us as something like the first input which will be there. Test input 1 will be the second input which is given. So basically you can say this variable and this variable is given to us. We need to decide on the bias, we need to decide on the weights.
Mm-hmm.
Getting my point, now?
Yes, yes, yes.
Okay. Okay.
Actually, this one
So
Manvi, this one actually I'm
yeah.
quite comfortable already
Okay. Okay.
because I need help on the perceptron algorithm. The next two.
Okay, okay, no problem. So yeah, here we are just thinking on how to decide on the bias, what it should be.
Okay, okay.
Okay,
Actually,
and
I was using it during the trial and error, or my thinking is wrong. I should be actually having some
so
systematic
yeah, no, no,
methodology.
no. Yeah, I think you. I so according to me, yes, I think there is a logical way to think. I think so. So yeah, maybe I'll just tell you that, or maybe we can think on it further.
Okay, sure.
Okay, yeah, great. So these are the two things which we have. Either it is 0 or a 1. Okay, and we need to
Mm.
decide on the weights and the bias. Yeah, so suppose okay, let's think on this. So yeah, so suppose I so let's start with setting the weights as 1 1. Let's just randomly set the weights as 1. Okay.
Yeah.
Okay, great. So let's try to see how our outputs look like. Okay, so I'll just write the outputs for the first one. So for 0 0, suppose the weight is 1 for both of it. So our answer would be bias. Okay,
Mm.
for this combination.
Yeah.
If the weights are 1, our answer is bias, equal to bias output. Are you able to understand or not?
If it's a
Okay,
0, it's a
okay.
1 1 or 0
Yeah, so I am talking about this input.
or 0 0.
So weight
Okay.
will be 1. Okay,
Mm-hmm.
this will be 0. Then this weight will also be 1 as we initialize both to be 1. And this again will be 0. So will be ultimately the answer for this would be by equal
0.
to bias
Yeah.
because we have a plus bias at the end. Okay.
Okay. Yes.
Yeah. Okay. For the second, our answer would be, I think, should be 1 plus bias. Can you see that
Mm-hmm.
for the
Yes.
second one?
Yes. Agree.
Okay. And for the third one, it will be again, I think, 1 plus bias.
Yes. Agree.
Okay, and for the third one, it should be 2 plus bias.
Yes.
Okay, and for the
Okay.
first one, what do we need as output? We need it to be 0. Okay. For the second one, we need the output to be again 0. You can see from the above lines, right?
Yep.
Are you able to understand this thing?
Yes. Okay.
Okay.
Yeah, that's the systemic way, right? Yeah. Okay. Yeah.
Yeah, so we need the outputs to be 0 for the first because as we know from here, we can see the outputs what we need. So
Mm-hmm.
we need 0 0 and then again 0 and for the last one 1. I have written the same here.
Yep.
Okay. Okay. And how do we calculate the input? We calculate something like this. Yeah. So basically, our output. So this thing is equal to linear combination. We have given the name as linear combination to the output of that operation.
Yes.
Okay. So if the linear combination is greater or equal to 0,
Mm-hmm.
okay, that will basically come as true here. There will be
Yes.
output as true, right?
Yes.
And
It's
if
a
we
boolean. Mm-hmm.
typecast true to int, it I think gives 1 as the answer. Okay, so this is what my thinking is. So int of true gives me output as 1,
Okay.
and I think int of false give me output as 0.
Okay.
You can try this also in your command prompt. So some days back only I was also confused about this. So I tried in the command prompt and I think I saw the int of true to be 1 and int of false to be 0.
Okay.
Okay. So, okay. So if our linear combination greater than 0 is true, then the output is 1. Can we say that?
It's true, then it's 1. Yes, correct. The output is
You,
equals to 1.
yeah, you can understand that, right? If this
Yes.
blue thing is true, then the output is 1.
Yes.
So basically, for this case, when we need the output 1, we basically need 2 plus bias. What do we need? We need 2 plus bias, which is our linear combination,
Mm-hmm.
to be, sorry, to be greater or equal to 0. Then only our output would be 1. Can you understand this?
Yes.
According to this statement, 2 plus bias should be greater or equal to 0.
Mm.
If we need the output to be 1.
Yes.
Okay. Can you tell me what do we need here? If the output we want the output to be 0, what should be the condition on 1 plus bias?
Bias must be equals to -1.
No, like you can just tell me what should be 1 plus bias. So according to this case, as we have 2 plus bias greater than 0, only then we'll get the output as 1. If we need the output as 0, what should be the condition on linear combination?
-1.
Or like not minus 1, basically you want to say less than 0.
Oh.
You're getting my point. So for true, so if we need the output to be 1, this should be true. Basically, linear combination should be greater or equal to 0. For false, what do we basically need? We need linear combination to be less than 0 because that is the only case which is left.
Oh, okay. That's the right thinking, right? I'm actually the wrong thinking.
Yeah, no worries,
Uh,
no worries. So now are you able to understand? Like when do we get a 0 output? We get 0 when this condition is false. And when is this condition false? If linear combination is less than 0.
mm, yeah.
Are you able to understand me?
Yes. Yes.
Are you sure?
Able to understand, but I'm not sure if I could implement that.
No, no. So
I mean,
there's nothing. So
I
there's
mean, now
nothing.
I can understand, but in the future, I can understand not everything.
Yeah,
Because I think
yeah.
the way you think is very systematic. Because that day I just play around the numbers and I got the answer right, then I go back to sleep already. Because I think this is the best way that you do it. Like the bias equals to 0. The way that you actually put into that formula. I mean, we
Yeah,
have to follow that formula first and then see what are the outputs. And then now your thinking is actually you try to use the linear combination, whether it's a
yeah,
true or false, and see
yeah,
which of the 4 cases that it becomes a true and which are the 3 cases
yeah,
become a false, right? So by that, you can actually understand that and use that to put into the
yeah,
bias instead of me trial and error. Now you can
yeah,
get the result straight away.
yeah, yeah. So basically, yeah. So that is what I want to be really clear. If you're able to understand. So basically, if the int is true, then only the output is 1. So basically, whenever the output we require the output to be 1, we should just see, okay, we want this formula to be true. So linear combination in the last case is 2 plus bias. So I'm just writing 2 plus bias instead of linear combination in this same formula. I'm writing the same here, but instead of linear combination, I'm writing 2 plus bias. And suppose for the cases in which we need the output to be 0 and we know the output is 0 when it's a false, what should be false? This statement. And this statement will only be false if linear combination is less than 0. So
Yeah.
that is the only thing which I wrote here.
Mm.
You're able to understand this?
Yeah. Able to
Okay.
understand now. Mhm.
Okay, very good, very good. So yeah, so I'll just complete for all the things. So for this also, as we need the output to be 0, can you tell me what should I write here? We need the output to be 0 then.
Bias must be less than equal or must be bias must be less than or equals to -1. -1.
Yeah, basically you are telling it right. So it's basically 1 plus bias is less than 0. that is this statement. You're able to understand, right? This is linear combination. It should be
Yeah.
less than 0.
Yeah.
You're able to understand this?
Yes.
Okay, great. So, like, honestly, tell me whenever you're not able to, okay?
Okay.
Okay, great. Yeah. So, let's understand these things now. And this again, as we need the output to be 0, we just write bias less than 0. As you know, the linear combination is equal to bias, so bias should be less than 0 for this case. Are you able to understand?
Yeah.
So because the linear combination is bias only in this case, and we want the linear combination to be less than 0 so that we can get the output 0, so bias is less than 0.
Yes.
Okay.
Yeah.
Okay, great. So let's. So this is so I'm telling you logically just to make you understand. But otherwise, when you'll see these type of cases, you'll be able to figure it out just by thinking in your mind only, like which should be the exact bias or something like that. But whenever you feel any issues, you can just make this type of thing and try to do this. Okay.
Yes. I'm jotting
Okay.
down the thinking.
Yeah, yeah, please, you can write down. Also, I'll be sharing this YouTube link would be there for this webinar. So you can again go to that YouTube link and you can see things. So that also works. Okay, so according to the first one, I have written bias less than 0. According to the second, I'm writing 1 plus bias less than 0. That is basically bias less than minus 1. Then for the third also, it is the same thing. So bias less than minus 1. And then for the last, what is our condition? Let me see. It's 2 plus bias greater or equal to 0. That means bias must be greater or equal to minus 2. Okay, I'll just do a revision for you. Okay, should I?
Yep.
Okay. So we started with what exactly we needed the outputs to be. So for 0 0 we wanted the output to be 0. Then for 0 1 we wanted the output to be 0 according to AND gate, and so on. Then we thought on what is our main output formula which gives us the output. Okay. Then we saw, okay, for so if we have the weights to be equal to 1, and if we take this case, what is the output? So the output came as bias, and we need the output to be equal to 0. But when is the output 0? So in that case we have this formula which gives us the output. So we saw that whatever linear combination result which we get, which is bias in the first case, what it should be less than 0 to have the whole output to be false. Okay, you with me till now?
Yeah.
Okay. So because we want the whole output to be 0, we want the internal statement to be false. And how can this be false? We want the linear combination to be less than 0. Only then the statement will be false. So we just wrote that linear combination should be less than 0. For the next case, we had the output to be 1 plus bias. We want the 1 plus bias to be less than 0 so that we get the second output. The same way we did for the third thing, we need the output to be 0. And the same way we did for the last thing where we wanted the output to be 1. So instead of having the linear combination less or equal to 0, we had it as greater or equal to 0. So this is how we made our statements, and accordingly we got some statements according to which we can decide what the bias value should be. You're
Okay.
with me till now?
Yeah.
So can you tell me one number? Okay, wait. Yeah, can you tell me a bias number which follows, like, which is true for all these statements? You can, okay. Can you substitute these three statements with one bias statement? Can you substitute these three statements with just one bias statement?
Bias less than -1.
Very good, very good, very good. Okay, so we are left with two statements at the end. Basically, my bias less than -1 and bias greater or equal to -2. Can you tell me any value which satisfies these both conditions?
Bias less than -2.
No, no, just tell me. So bias less than -2 doesn't, I think, hold for it because bias should be greater or equal to -2. It can't be less than -2. You can tell me one number which follows, which satisfy both these conditions. Take your time, no worries.
Bias less than or equal to -2.
Yeah, basically, so you don't need to tell me in less or equal to. You can tell me one number, any
Um,
number which satisfies.
-2.
Okay, -2. Let's think on that. -2. Yeah, yeah, you are correct. You are absolutely correct. This satisfy both of them because it's greater or equal to -2, and it is less than -1. Can I write -1.1? Does it satisfy both these conditions?
No,
Why?
because the second condition bias uh, bigger or equals than -2 is not satisfied.
Okay, -1.1 is bigger than -2 or not?
No, it's less than.
Okay, think again. Okay, how is our number line? Oh, sorry. This is how our number line is.
Yes,
Yeah, so -1.1 would be somewhere in between these two,
yes,
and it is greater than -2 then.
yes.
You with me till now?
Uh,
Yeah, yeah, just take your time. Don't like take all of your time. Nothing to worry. This is how our number line looks like. -2, -1.5, then -1, then 0, 1, 2, and so on.
so the -1.5 is bigger than -2.
Yeah, yeah, that is true.
And I have to satisfy this condition where the first one I need to bigger than -2 means 1 -1.5 is okay, but
Yeah,
I need to be less than -1, which
which,
is means uh, smaller than -1. So
yeah,
1 -1.5 does satisfy both of the
yeah,
condition.
yeah, very good, very good. Yeah, you are right. You're absolutely right. You're absolutely right on this. Also, I can tell you one more way to think on these. So, suppose we have 1.1 less than 2. Okay. If we introduce negative signs to both sides, the like the sign of greater or less, that like that becomes the opposite. So if I introduce minus sign on both sides, it becomes like this. Okay.
Right.
Okay, so yeah, so you can always, so whenever you're confused, you can just make the number line and see on things, or otherwise you can just write normal statement like 1.1 greater less than 2, and then you can just introduce negative signs to both, and you can just make this condition opposite, which was initially less than, it becomes greater than.
Yes.
Okay,
Okay.
great, great. good that you're able to understand things. And yeah, so here, as you can see, we have a lot of numbers. As you said, minus 1.5, minus 1.2, so many numbers we have. So these all could be biased. So I used, in my case, I just used minus 1.1. So this way you directly have the answer. Actually, I have done some changes to the code, but if most of them are comments, we can check. So if I do minus 1.5, I don't know if I did some changes to the code, so I can test run. And nice, you got it all correct. So yeah, so minus 1.5 also does it. Other numbers which you yourself told were minus 2 also. So let's try with that. So without doing any trial error, I just got some numbers. I'm just using them and everything is coming as correct. So suppose I have minus. So if I do something like minus 2.1, which I think doesn't hold the second condition because it's not greater than minus 2. It's actually smaller. So if I test run, let's see how things are happening. Oh, you got one wrong. So you are able to understand, right? So when you are
Yes.
using the wrong bias, you are not getting the correct answers. So let's try minus one. As our say condition says, it should be less than minus one. Let's try minus one. So again, I think we should get wrong answers. You got two wrong. So this is how you can directly get the answers, and you can also explain your interviewer like this is how we do. So they'll be a bit logical and be a bit
Yeah.
okay.
Okay.
Great, great. Okay, so I think you're able to understand. It's fine if you're not able to like think on, okay, later on will I be able to manage on my own or thing. So with practice, you'll understand these things. So nothing to worry on.
Okay.
Yeah, so this is how you think on bias. For Zor, there are some things. Yeah, so yeah, tell me what else do you want to understand or something? So this
I
is how
think
you think on perceptron algorithms, basically. So you initialize the weights, I think, with something. Then you think on what should be the bias, and you directly like write the code. Code, I think you are fine now with the code of perceptron, and I think you are like well equipped with the things. You can just see these things first. The first thing which you should see, as in and we saw 00 should be false, 01 should be false, 10 should be false, 11 should be true. In the same way, you can just make this initially. This should be your first step. Like after making this, you know what should be the output for which input. Then you can initialize the weights with some random value or something, maybe 0 1 or something like that, and then you can think on what should be the bias according to the same thinking. And I think you are good to go with the perceptron stuff.
how about the perceptron algorithm? This one actually is very, very difficult compared to the logical
Okay.
this one. Because here actually I have a few doubt actually on that. The first thing is actually on during the if I want to move the line to the right, right, actually I have to add. I use the sum to add the
Okay.
ax, right? And then if
Okay.
I want to move the line to the left, I have to move that to minus. And
Okay.
I'm actually using the learn by heart because I actually don't understand why I need to minus. But
Okay.
actually, I just come up with a way, and then I just need to memorize it. Is there a way that actually we can know that how we want to add, and instead of like memorizing that, to move the line to the right?
Oh, okay. 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 So basically, you were saying, so you get a line which is somewhere and you want to like move it to the right.
Yes,
Okay,
like
okay, okay.
like
Got
a
it.
red line,
Okay, yeah,
like
got your point. Got your point. So in this video also they tell you that, right?
they just tell me that I need to add or minus, but I think they don't actually explain why we
Okay.
need to add or minus. But
Okay.
actually, I already learned that by heart, so I don't want to care about that also. If
Okay. Yeah, yeah.
this is my.
So,
Mhm.
so yeah, actually, it's some cases or maybe later on also, it's good that you have remembered it by heart. So it's fine that way also. But yeah, so okay, so can you tell me what value do you increase or do you increase bias and all bias?
Actually, this code I having troubles to understand.
Okay,
Actually, here also it all putting all the defines, and I can only the most I can print out the x min x max to see how the values that I got, and then go back again. So I actually I couldn't I couldn't understand this very much.
okay,
So I skip it because I don't understand it. So this one,
okay,
like the S min max, I try to understand first the data.csv, why there is a one or zero in the bias.
okay.
Is it intended, or there's a way of want to train the algorithm is using that at the data.sv file? There's one and zero. And then
Yeah,
second thing, like I don't understand like the prediction. Okay, like this there's a one, okay, the np multiplications multiplications, right? xw x comma w plus b, and then they have this element zero. Then I don't understand why is the element zero there, because I try to print out without the element zero and print out the element zero without or with the element zero, I getting the same numbers. So I don't know why people need to put a zero there. So this is the problem that I'm having, these
basically
predictions.
in yeah, okay, I got your point. So basically we need to like think on why we are writing it this way and stuff like that. Yeah. So okay, okay, I'll again okay, again take this to my plate only and I'll think on this. So one thing you have told me about the not perceptron, right? And one would
Yeah,
be
it
this
looks like
algorithm.
this one is I don't understand. That one is maybe the question
Okay,
is
okay,
a
okay.
bit doubtful.
No worries, no worries. So okay, so okay, this one also I'll take it to my plate and maybe I'll explain this also in the chat. Okay, so can you tell me again the issues you face? So one is
Okay.
when how do we shift the lines, right?
Yes, like the plus or minus. How
Okay,
do
and
actually the
by
concept
increasing.
behind that? The
Okay,
second one is like this one. This line on the line number 11. The
11.
line 11, there is a return the step function NP
Yeah,
multiplication multiplication x w, right? So
yeah,
I mean the NP of the multiplication matrix multiplication x and y is actually I multiply both of them and then add
yeah,
the
yeah,
sum value to the bias and then
yeah,
do a
yeah,
step functions, right? But
yeah.
but the zero there, I don't know when are we supposed
Okay,
to do that and where is the zero?
okay. Okay, this I think we can think on now also. Okay, so step function. Okay, this is the step function. Okay, matrix multiplication. Okay, so this must be okay. So you are saying without zero also. So okay, can you try printing this value? So do you know what this value prints out to be? I think we
Uh,
can do that here also.
okay.
So yeah, let's do that. Let me see. When am I calling the prediction function? So where do we call the prediction? Mm,
Uh, there is some function
yeah,
calling the
here,
prediction.
yeah. So in the perceptron step, we call the prediction, right? So
Yes.
let's try to print. Let's try to print. What does this give us? So you can always try these things. Like
Yeah,
what does it?
actually, I tried that one. Yeah, because
Yeah,
yeah, the day after I talked to you, right, I tried to
yeah,
print out
yeah,
everything already if I don't understand. But this one, I
yeah,
still
yeah.
having problem to. I
Okay,
think that's the
no
best
problem.
way to do that. No choice already
Yeah.
because I cannot understand now. I print all the shape like in the all the shape, all everything, every line I print out. Then I can know what they are doing because I don't understand. I think
No,
it's a
that's
good
good.
way because there's
Yeah,
no
yeah,
choice, right? How I can learn.
yeah, yeah. It's actually a good way. You should, you should. So I'll write in the group. You should print all the shit. Yeah, yeah. Okay, okay. So this works. Okay, let's try to print this and let's try to see what do we get the results as. I don't know if my code here is correct or not. Let's see. Okay, yeah, I can see. Okay. So basically it's an array, right? So you can see it's an array. Or a list, I mean to say.
Uh, you mean an array is means that okay, you mean a list is you mean
So
this prediction is a
yeah,
list,
yeah.
but the
So
list is only have one element inside.
yeah, it just has one element inside. So I think
Just has
why,
one element.
yeah, so I think why you're not facing any issues without doing the zero is because it just has one element. So according to that, it works like this thing may work. So we can also try that. Let's try that also. So we can, so that we can understand like why this thing works. So you also had a question, huh? Like without zero also this works.
Without the zero or the zero, actually it prints the same value, but is one array or not
Okay.
array thing. I think one is with encompassed in array form and one is without. Actually, yeah, something like that. But I cannot understand the detail.
Okay. So yeah, so we can just see, suppose I don't have this zero here. So the function would like accept this thing, this whole thing, which is ultimately an array. Like array or list. Sorry, I use the word array, but list and array, these are the same. So yeah, we can just see how this thing works. So I can just copy this and I can just see if greater or equal to zero. So let's see what it does. So you are getting my point, right? So I'm
No,
saying,
what are you
yeah,
trying to
yeah.
equals on?
So
Yeah, the
yeah, so
purpose.
basically, as you are saying, suppose we don't have this zero. Suppose you have a thinking like we shouldn't have this zero or something like that. So do you think that way or
Actually, I just print that without a zero and one without with a zero. They give me
yeah?
both the result, but I don't understand how to interpret that.
Oh, but why did they give you both? Both of them can't give you the same results, right?
They give me
Because
the same result.
okay, because in this case, when I'll print the zero, it won't give me the same result. It will basically be okay. I'll just do this. I'll just do this. Then I'll just write first element and then okay. So let's try to print this. So first will be an array and second will be one element.
Okay,
Okay. So
first.
yeah, it shouldn't be the same. We can see on where did you try to print and stuff. So, but it shouldn't be the same. Okay, let's see. Let's see if so you can see the first is a list, but when we so we in the first element, how do we assess that element? We tell okay, give me the zeroth index of the list. So this is
Mm.
how we do. So initially it's a list, and how do we assess the element of the list? We just tell that give me the zero index of the list because it's just one element. So it gives me that element. So it shouldn't be. So maybe you printed it wrong or somewhere else, but it shouldn't be the same.
Uh, I think I print out the same way, just that I don't understand this line. Now, you are telling me that because this
Yeah,
list is only have one element and they are
yeah,
printing out the first element, that I think that
yeah,
explains why as well. Because the number is actually the same,
yeah, yeah,
1.96 and 1.96, right? Yeah, it's
yeah, yeah.
exactly the same way that
Yeah.
the same data that I got that day, but I don't understand why.
Okay,
But now I think I'm a bit clear already
great.
now. Mhm.
Great, great. Okay, for the shifting of the line, okay, I'll go through that because I want to tell you the exact solution. So I'll also just go through the content again a bit so that I understand or I remember what was the exact thinking we should make. Okay, so
Okay,
yeah, this I'll tell you the shifting of the line and the not one I'll tell you. So two things I'll just tell you after the call. Okay,
okay.
also, yeah, also you asked some of the doubts. So are those doubts the same you're asking here
Hmm, I
on
asked too many
Slack?
things already.
Yeah, on
I
the
think I asked
same.
too many things. Sometimes I need to go back to the code and what I write down to see that.
No problem. Also, you asked one of the doubts in the group about shuffle true.
Yeah, shuffle through. Why they need to shuffle through?
Okay, can actually my computer is getting a bit slow. So okay, can I know where is that code or something? Can I know that?
Mm, What is on the new neural network already? Let me go there.
Yeah,
Mm,
just tell me the lesson so that I can just see.
Actually,
And
if I sorry, Manvi, I think this one I also need to understand why the bias sometimes is one and one sometimes is zero.
okay,
At the data.csv, what is the purpose of people putting a one and zero there?
okay. So it's so generally changing the bias, like you just change the bias or something so that you get the correct results. I think it's just that. But okay, so I think you asked this also in the Slack that generally they are using one and then they started using zero.
Yeah,
Yeah,
because I print out
yeah, yeah.
everything for the output and then I saw the data actually going through all the data, no matter
Mhm.
it is a plus, a minus, or a zero. A zero meaning that I'm fine, right? I'm good. I no need to
Yeah,
shift my lines. They're actually
yeah,
going
yeah,
through everything. I run through the code and the
yeah,
output that I see is actually they want run through hundred data.
yeah, 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 yeah. And the answer is correct for all of them, right?
Because I made myself so complicated that I don't understand what I'm printing out already.
No, no, okay, okay. So your okay, one question is why do we use zero and sometimes one? What is the logic? Yeah,
Okay, yeah. I
yeah,
because this
that.
one I have so many doubts. I don't know what to ask already sometimes. Because from here I see that it actually run through the whole data, 0 till 100. Zero
uh,
till 100 of the data in
yeah,
change to the period.
yeah,
I
yeah.
see.
So one thing which think is, so as you can see the data itself. So as you can see, so for the data having zero bias. So suppose I start with here from here. I can see most of these are greater than, so both of the data points are greater than zero point 0.5. Can you see that? Most of them are
Mm,
greater than zero point 0.5.
yes.
Yeah. And for the
Yes.
ones, you can see most of them are less than zero point 0.5. Like
Yes.
most of them, I'm not saying all, but
Okay.
most of them are so it could be, so as I said, it could be according to the data we adjust our bias so that the results are correct. Okay, so that is, so basically we adjust the bias so that our linear combination comes out to be the correct thing which we need. Maybe if we need greater than zero or less than zero or something like that. So that could be a case. I'm just telling you that that could be a case. But okay,
Mm,
maybe I'll just again go through and maybe I'll tell you a better answer after this. But yeah, but just to have it in your mind, that could be a case.
mm,
Okay.
yes.
So that could be the case. That's why we change the bias so that our linear combination just gives us the right answers or something like that. But okay, I'll just go through this also and I'll just tell you this also. So yeah, so I'll tell you this.
Mhm.
Okay.
I'm checking back what I actually don't understand here because yeah.
Oh, okay, okay, no problem. So because you told, I know the why they fundamentally put in different. Okay, so this is what you asked. This is what you asked.
This
This
one you
is
already yeah, this you
okay,
already
great.
explained. Yeah, it's good. Yeah, this one
Yeah,
is
this
okay. Prediction is
also,
comfortable already.
yeah, this also I think it should be plus B. So bias should be there in the formula, as you know we use it all over. So I think it should be in the formula. So yeah, again maybe I can see that, but this is a small issue I think. So basically, perceptron issues, two perceptron issues, and one not perceptron. Okay. So these are the ones which I know. Okay, one you asked here. So let me see that. Let me see. Does anyone know shuffle to what? Yeah, can you tell me the part where I can see this?
The part if I go to neural network,
Shuffle to.
it should be that lately that I study this one. I think should be PyTorch maybe PyTorch inside the PyTorch. because I'm
Train
rushing
load.
through already. I think I'm
Yeah, yeah, no
missing
problem,
out
no
a lot of
problem.
things.
Yeah, yeah. No problem. Just yeah, just calm yourself and like try your best. So go fast, but you should be able to follow everything. That is important. It's fine. You have may have to give more time, but yeah, just don't like. But still, I think you are asking your doubts, so I don't think you are just going walking through. You are understanding things, so it's fine. It could be that you don't remember some things after one or two lessons, but at least you understood it at that point. So I'm fine with it. And in the project, if you have understood most of the content, then I think in the project also it should be fine. Okay, so train loader. Okay, so this looks some workspace. Looks like some workspace because you can see I created train loader and all. Okay, so I'll just read this. I think I should be done. Loader I created with the batch size and shuffle to. The batch size is the number of images we get in one iteration from data and pass, often called a batch. And shuffle to tells it to shuffle the dataset every time we start going through the data loader again. But here I'm grabbing the first batch so we can check out the data. We can see it's just a tensor, so 64 images. Okay. Okay, so yeah, tell me a question now.
Mm, After it do, why I need to set the shuffle equals to true after
Okay.
we get the image from one
Yeah,
iteration.
so basically what happens is okay, so the thing in neural networks is you should be very so we should be very comfortable when we are training our neural network, okay? So when we are training our neural network, we want the images to be really random. We don't want our neural network to train. Okay, so what happens, so I'll just tell you an example. So in the project also what you'll be doing, so
Mm,
suppose there are 100 dog images, okay? So
okay.
these are dog images are and you need to predict a dog image later on, like you need to train a model which needs to predict the maybe the breed of a dog, okay?
Mm,
So I'll be training a model. I'll be giving that model 100 dog images. I'll be training that model on those images so that at the end of a training, so 100 images I'm saying a bit less. Actually, the images should be a lot more than that. So when I'll train my model later on, I'll just ask that model to predict dog breed by showing it a new image which won't be present in the trained images.
mm,
Like a training, if a training took place through our 100 images which we provided, I'll get the 101th image. I won't train my neural network for it, but I'll just ask the neural network, what do you think the breed of this dog is?
mm,
Okay.
okay.
Now the thing is, in real world, it's not sure that the image that people will show the neural network would be a straight image. It could be a 90-degree rotated image. So
Mm,
because you in real world you see a lot of images, the dog could be even rotated by 90 degrees or 180 degrees, the image of the
yes.
dog, right?
Okay.
So we try our best when we are training our model. We provide 100 so 90 images of 0 degree angle images, and 10 images, sorry, 5 images of maybe 90-degree rotated, and maybe five images of 180-degree rotated cat, oh sorry, dog images. So we try to make our data as random as possible so that whatever image is shown to the neural network later on, our model is able to predict it.
Mm.
Okay.
So is that the meaning that the rotation like 0, 90, 180, and 20,
Yeah.
20,
Yeah.
270 will be one of our hidden layers?
No, no, no. So the
No?
thing,
Okay.
yeah. So the thing is, we'll provide our images. So if we have 100 images, we'll just apply some transformation to the maybe the last 10 images, and we'll just make those 90-degree rotated, and we'll train our model with those rotated images.
So those 10 images inside the 100 is
Yeah.
rotated. That 10 images is a part of the 90 images.
Yeah. Yeah, that 10 images are a part of the 100 images on which we train our model.
And they are actually independent from other images.
Yeah, they are independent. So
Mm.
we can rotate the images, we can do some other transformations which you'll see in the project or maybe in the content. How do we transform the images so that we make the data so random, like not just straightforward dog images, we make it so like broad type of data so that whenever a person shows an image later on, it should be able to predict even if the image is rotated by 180 degrees or something,
I
or some other type of transformation, like if the person just shows maybe 80% of the dog and not the last two legs or something like that, still we want our model to predict it. So that's why we introduce all this randomization. So on the same way, why we are doing shuffle true, because suppose if you have, so if you have a data in which maybe, so suppose maybe tomorrow you have started clicking images of dogs. Okay, and you click the image of one dog maybe 10 times in different angles, or maybe one from the front, one from the side, and stuff like that. So you have all those 10 images together in your image folder. And then for the other dog, you again clicked 5 image of the same dog but in different angles. So I don't want the training also to be like this. So suppose there are 10 images which are almost the same, which our model is getting trained on. Then there are 5 images which are of the same dog and stuff like that. So we again want our training to be really broad and randomized. So we shuffle those images so that suppose it's nothing like the first 10 images or 15 images are of the same dog. We want the images of different dogs placed at one place. Suppose on the first place it's one dog, and then the same dog comes in a different angle but in fifth place or sixth place. So because of that we do this shuffle through.
I see.
You
Okay, now
getting
I
my point?
understand that. Yeah, I get that. I'm getting a point.
So
Yep.
so these all things which we do is just so that our training of the model is a bit on the broader side and a bit better, and it's not a bit biased or something, because we have the same 10 images initially and then the same 10 images of the same dog as a batch in the second batch or something. So that is, I think, the main reason for which we do this shuffle.
Right. Okay. Yep.
Okay.
Okay.
Okay, great. That you are able to understand.
Okay.
Okay. Yeah. Any other thing for the timing you want to ask?
No, no, no,
Okay.
nothing else.
So where are you currently? And so yeah, just I don't. So I want you not to be stressed or something. Just try your best. Have your speed. Give it more time, as much time as you can. But just don't be stressed or something. Give all of your energy to the course itself, and give and get good breaks also in between. And I think we should be able to manage. There's still so when does this nano degree end? Do you know that? Hello.
Hello, hello.
Yeah, what happened?
I go back to the. You asked me where I was. I go back to the university and then I lost. I
Okay. Yeah, so I'm saying, do you know when does this nano degree end?
June 30th.
Yeah, June 30th. So yeah, I think Liv, we have some days, so I don't think you should worry. So you're currently on which thing?
Yeah, later I'm too fast browsing that. I lost. I think it's in the neural network. The PyTorch. I on the last part already, but I skipped the perceptron algorithm because I cannot
Okay.
understand.
Okay,
So
no
I
problem.
need to go there back again. But some of the
So
basic fundamentals, I'm not sure I'm strong enough to go through that.
yeah, no problem. But at least you understood it at that point. Like when you were going through that, were you able to understand it?
Yeah,
Okay.
I think the PyTorch was saying that it's using some back propagations method,
Yeah.
right?
Yeah. Yeah.
Actually, they'll go to and forth like that through the
Yeah.
network.
Yeah. Yeah, yeah, yeah.
I need to go back that again because maybe
Okay,
I need to
okay,
study more. I
okay.
maybe
No problem, no problem. That is fine. So you can initially walk through, and whenever you have problems and you know, okay, this is what I need to do, then you can go back and see it again.
yeah.
Okay, so back propagation, feed forward, these are important things. Gradient descent is important. Then these things are important. So you can just try these and understand these again if you want. Okay.
Mm.
And if any quizzes are there, just like try your best to do those, because if you will be able to do it, if you are able to do the quiz, then it will be really easy for you to actually do it in the project.
Okay.
So whenever there are quizzes, just if it takes time, just give it some time, nothing to worry. And
But the quizzes in
e-
here is less, right? The quizzes
yeah,
in
yeah,
this one is less. It's more on the
yeah, yeah,
video and then telling us. I
yeah,
think the video, the quizzes is more. You mean in the PyTorch, right? PyTorch there is more
yeah.
quizzes.
Yeah, in PyTorch there'll be more quizzes, and then in the project it will be most of this knowledge will be used there and stuff. So yeah, so wherever there are quiz, just do that so that it's if you are able to do the quiz, then in the project it will be very easy for you to do stuff. Okay,
Oh,
and yeah, good that you've asked some things in the group also. You can ask it further also, and so three doubts of you I have. So I'll just try my best to make you understand those. And
okay.
so that's it. Yeah, just try to give as much time as you can. So how's your work going on, your work life? So how's your work? Is it hectic nowadays or is it fine?
Now it's less hectic. That's why I can put
Okay.
more time. Yeah.
Great, great, great. So yeah, try your best. I think you'll be able to manage. Just go through these very, like understand these things perfectly, so that in project I don't want you to be stressed out or something, because you have to go again and do stuff, and then you must be thinking on I should have done it better at the content part itself. So I want you to understand these things. It's fine if you like if you skip perceptron or stuff, but most of it like try to understand this now only, so that in the project you are not stressed out or something. And so that you're not like stuck.
Okay. It's a stupid question. The now actually let me think if like I have a inputs layer, I have a hidden layer, and I have the output layer. Each of
Yeah,
the inputs times the weight, I have to simulate the data. I need to simulate the data in each stages, right?
yeah, sorry, I lost you in between. What you're saying?
That means every stages that I go through, I need to simulate my data to make it a
Yeah,
probability every
yeah,
time I go through, not at the end only, at the each of the operation I need to
yeah,
simulate my
yeah,
data. Is that
yeah.
the
So
correct?
yeah, so basically what happens is so I also wrote something related to training set, validation set, and testing set. You can also just go through that. So you can also just go through that also. It's present in the group itself. I think I told it to eom. Okay, so you can
Mhm.
just go through that also once. And basically what do I do is so okay, so yeah, if you go up a bit. Yeah, so this is what I told to eom. Just go through this later on. Okay.
On the May 29, is it?
Yeah,
Okay, okay.
yeah. Yeah,
May
so
20.
so
Okay,
what
okay.
happens is, first we initialize our weights and our bias to be something random. Okay.
Mm-hmm.
Okay, so I'll also tell you this. So the bias thing, for the bias thing, what happens exactly in the neural network is you don't need to think on what should be the bias. You just randomly
Mm-hmm.
initialize the bias. You train your model. You
Mm-hmm.
keep on changing your bias and
Mm-hmm.
your weights according to your model results. And at the end, when you have
Mm-hmm.
a good accuracy of your model, you just get the correct values of bias and weights. Okay, so ultimately in neural network you don't need to think on what should be the bias. The machine or the training itself takes care of what should be the weights and what should be the bias at the end of the algorithm, like at the end of the training.
Okay.
Okay,
Okay.
so what happens initially, you initialize the weights and bias to be some random values. You start the training, you get the sigmoid, you see, okay, the probability or something, you see the results, okay, the result for this input comes as maybe, so the probability of this input being digit 9 is suppose point 0.2, but you know the actual output should be 9, so the probability should be at least more than zero point 0.5 or something. So I'm saying,
Uh-huh.
so let's think on this thing. So suppose the input is a handwritten digit 9. Okay, suppose the input is a handwritten digit 9.
Okay.
Actually, I think I'm losing your voice in between. Hello. Hello.
I hear you.
Yeah, now I can hear you. Actually, my charging is also less for the laptop. So you can hear me now?
Yes.
Okay. So, yeah, wait, I'll see where my charger is. Okay, I found it. Yeah, so I'm saying, so suppose there's the input is a handwritten digit 9.
Mm-hmm.
Okay, and as we know, the output for this input should be 9, because as humans we know the handwritten digit is actually 9, right?
Right.
Okay, and
Right.
suppose when we initialize the weights and bias to be some random value, started with, the output came out to be point 0.2 probability for the 9. So there are some 10 output units, and in the ninth unit it's saying the probability of the number to be 9 is point 0.2. Are you able to understand?
I couldn't hear the number that you say. The of number 9 is what? Just now you mentioned the probability of number 9 is hello? Hello?